Stoichiometry. What is stoichiometry? Stoichiometry is the study of quantitative relationships or ratios between two or more substances undergoing a physical change or chemical change. In stoichiometry, we use dimensional analysis to convert between grams, moles, and atoms. The unit grams accounts for the atomic mass, which can be derived from the periodic table. The unit atoms accounts for the amount of moles in the chemical equation, or the coefficient number that comes before the chemical symbol.
What is a mole? No, it's not the cute fuzzy animal that crawls in the ground, or the other fuzzy creature that lives on your aunt's face. The unit moles is defined to be 6.022 times 10 to the 23rd atoms, molecules, or some other unit. So what is the point of the real scientific mole? It serves as the base conversion unit between grams and number of atoms used in dimensional analysis. Thanks.
The unit mole is the coefficient number of an element, which indicates how many atoms of that element there is. So to find the molar mass, we multiply the atomic mass of one atom of the element to the number of atoms that are present, or the coefficient number. For example, the molar mass of SO2, sulfur oxide, is 64.07 grams per mole, because the atomic mass of oxygen is 16, so 2 atoms of oxygen is 32. And the atomic mass of sulfur is 32.07. Since sulfur only has one atom, the molar mass equals the sum of 32.07 and 32, which is 64.07.
Balancing equations. Before starting to work through dimensional analysis and stoichiometry, we have to balance the chemical equation, or the number of moles we are working with, to allow for a proportional mole ratio. Let's demonstrate balancing with an example. We start with lead sulfate, which is PbSO4 and lithium nitrate, LiNO3, yielding lead nitrate, PbNO3 and lithium sulfate, Li2SO4. It's easy to balance the equation if we list out the amount of each element on each side of the equation and try to make them equal by multiplying the coefficients.
Now that this equation is balanced, we can figure out the grams, moles, and atoms of any compound we want to by using equivalent ratios to convert between units. For example, we can find out how many grams of lead sulfate and how many grams of lithium nitrate are needed to make 150 grams of lead nitrate with no extra material. First, we would find the molar mass of each compound. The molar mass of lead sulfate is 399.34 grams. The molar mass of lithium nitrate is 68.947 grams. Finally, the molar mass of lead nitrate is 455.228 grams. Next, we set up two different grids for dimensional analysis, one for the conversion between grams of lead sulfate and grams of lead nitrate, and one for the conversion between grams of lithium nitrate and grams of lead nitrate. As we work through the conversions, we write each value as a part of one big ratio that will cancel out like units in the end. First, we write down the amount of grams we start with, 150 grams of lead nitrate. On the bottom, we write 455.228 grams of lead nitrate, its molar mass, as proportional to 1 mole of lead nitrate. Next, on the bottom, we write 1 mole of lead nitrate as proportional to 4 moles of lithium nitrate. These numbers were derived from the balanced chemical equation. Finally, on the bottom, we write 1 mole of lithium nitrate as proportional to 68.947 grams of lithium nitrate. After units cancel out and numbers are multiplied together and divided between the top and bottom, we find the answer we were looking for, 90.874 grams of lithium nitrate. To find the amount of grams of lead sulfate needed, we would replace it with lithium nitrate and go through the same process.